Okay, today's March 7th, 2012. We're on lesson 2.3. I'm going to give you guys a quick algebra lesson on how to show optimizing area and perimeter for the shapes we're using, okay? So the first thing we need to discuss is four-sided shapes, okay? So if they're telling us to use rectangles, and they're giving us the area of the rectangle, let's say. They're telling us that, for example 1, the area of the rectangle is 144 centimeters squared. Okay? What is the most efficient shape, or four-sided shape, I should say? Square. Square, that's right. So, even though they've told us a rectangle, squares are rectangles, so we need to know that, okay? So we have a square here. This is a rectangle. Now, all squares are rectangles because a rectangle is a four-sided shape with 90-degree angles, and the sides or opposite sides are parallel, which a square fulfills, okay? So squares are rectangles. Not all rectangles are squares because this guy here, his side lengths are different, okay? So you have to keep that idea in mind. So when I go to show this, we're going to talk about area of a four-sided shape. So the area of a four-sided shape, who can tell me area is equal to what? Length times width. Real simple one we learned years ago, right? Normally it looks like this on a rectangle. Now if I go to put it on a square, length times width, do I need two separate variables? Now in this one I definitely do because I'm going to have two different numbers. But in this square, are the numbers going to be different? No, so I can just use one variable. So let's call them both the length, okay? Because we know that, or we could even call them the sides of a square. We know that they're going to be the same. So in other words, this used to be the W, right? I can replace this W with length because the area of a square is the same as our length times our length. How can I simplify length times length? Length squared. Area equals length squared. Okay, good. Now, they did give us information. What was the area of this rectangle we were working with? Anyone remember? What was the area? We said at the very beginning. Perfect. So, I'm going to replace area. Oops, wrong button. I'm going to replace this area with 144 is equal to L squared. Okay. Now I got to isolate L. How do I get L by itself? What do I do to both sides of this equation? Square root. Good. I need to find the square root of 144 and the square root technically of L squared. Now what happens on this side is because they're opposite operations, the square root and the square cancel each other out. We just have L. And L is equal, what is it? Square root of 144? Perfect. So, we now know that the side of this, did we say inches or anything? Centimeters, okay. So we know that the 12 of this is 12 centimeters. The side of this is 12 centimeters. But the question asked us, what will the optimizing perimeter be if the area is 144? How do I find the perimeter of this object?
12 times 4.
Perfect. It's a square. Perimeter is equal to 4 times whatever our length is. Since our length is 12,
48.
amazing. Perimeter is 48 centimeters. Is it squared or no?
No.
Why not?
It's a length.
Why isn't it squared?
Because it's not area, it's perimeter.
Amazing. Okay, the second example I'm going to show you guys is, again, we're going to make a four-sided shape. Okay? The only difference is this four-sided shape. We only actually need three sides of fencing because some object, and we'll say in this one it's a river, takes up the other side. So I don't need to use fencing to cover up that area. So I'm still making what would be considered, if I were to highlight this, a four-sided shape. But again, I only need three sides of fencing. Now they've told us, let's say in this question, that we're going to maximize area at 40 meters. So we need this pen here to be 40 meters squared in area. Okay? So this entire space in here needs to be 40 meters squared. I need to figure out what my lengths and widths are going to be. This will be our length, and both of these will be our widths. Okay? Now, I'm going to just tell you what the ratio is in this one because in the other examples, in the other video, we walked through it. But in this one, what ends up happening is your length should be twice your width. Okay? And in other words, the reason this also works is because remember when we're optimizing area and we have a square. When we have a square, this same idea works because if this is our length, a square is the length and its width are the same. So the length and the length would be the same. Well, if I take this side here, whoops, that's not what I want to happen. So if I were to grab this length here and move it, this side and this side end up being the same if the length is twice as long as a width. And I'm going to show you what that idea means. I know it looks a little confusing right now, but we're going to move this back. So in other words, we make an equation, okay? We know that the area is length times width. I'll fix that stuff there. Okay, there you go. So area is length times width. We're going to set a perimeter also. Perimeter of this object is going to be our length plus 2w. Okay? Because there are two w's here. Perimeter is length plus width plus width. Well, if there's two widths, we set it up as 2w. Okay? Now remember, I told you the ratio that works best is if your length is equal to 2 times your width. So in other words, I can replace L with 2W, okay? Because I know that this length is going to be equal to 2 times whatever the width is going to be. So when I go to put it into my area formula here, I'm going to replace my L with 2W. So we're going to work down here in red now. Area is equal to, we'll replace L with 2W times W. Okay? We said that our area was 40, so we can replace A with the number 40. Now here's a question for you guys. What would 2W times W be?
3W.
Oh.
2W squared.
2W squared. Okay? The reason that is when we multiply these terms, imagine there's a 1 here. 2 times 1 is 2. And W times W, remember we did exponents? We just add the two exponents there. So 1 and 1 gives us our 2. So our formula now to find out what the width of this is going to be is 40 is equal to 2W squared. I need to isolate for my W. Okay? Now I know you guys know bedmass. When we're solving things, we follow bedmass. When I'm isolating for a variable, I do reverse bedmass. Okay? So right now I have multiplication and I have an exponent. If I'm doing reverse bedmass, that means I deal with the multiplication first. I need to move that 2 because we're trying to isolate this W. So because that says 2 times W squared, how do I move the 2 over? What would the opposite operation be?
Divide.
Good. So we divide both sides by 2. 40 divided by 2 is 20. Gives us our W squared. How do I get rid of the square?
Square root.
Good.
Multiply.
So we square root both sides. These two will cancel each other out. Our width is going to be, and we're going to actually have to bring up a calculator here. What is it again? 4.72? 4.72 is our width. Okay? So with that information, we go way back up here. If our width is 4.72, and we had this formula here, how do I find what my length will be? Multiply that by 2. What is our length going to be in this case?
9.44.
9.44. And we're going to test these numbers to see if their area is roughly 40. Okay? So in other words, I got to take 9.44 times 4.72. 4.4. Oh, okay, thank you. Beautiful. 472. Okay, so this is to calculate what we've actually found for area. We're trying to get as close as possible. Because we rounded a little, we'll be extremely close. When we multiply these two, what do we get? This is our length and our width, remember? What's the matter? So because I wrote the number down wrong to start, yeah, you're right, this changes a little. It's okay, it's okay. 8.944? Okay. So we'll switch this length to 8.944.
39.9975.
Area becomes 39 point.
9975.
So, almost,
75.
this is fine, this is fine. This is almost 40, exactly. It's roughly 40 meters squared. So that's what the process was to find this out, okay? The ratio that was extremely important is that when we're looking for a four-sided shape, but we only need to use three sides of perimeter, the most optimal area is when the length is twice as wide as the width. That's very important. You guys need to know that for your quiz coming up.